Good morning. Good morning. Today we are going to see about logic gates. What is logic gates and how it is related to electric circuits? Logic gate is nothing but a device that performs a basic operation on electrical signals. What are all the electrical signals? Why it is said to be it is operating on electrical signals? We are going to give the inputs on the logic gates. For example, if I am having a NOT gate, the basic gates you know already. What is a NOT gate? It's an inverter basically. If you are giving an input signal A, it is A of value 1, it has to give an output of 0. Okay. So the signal is your electric signal. That is how it is related to your electric circuits. So a device that performs a basic operation on the electrical signal, that is said to be a gate. And what is circuit? If I need to perform an operation, any operation, for example, any digital operation, in day-to-day life, everything is digital. For example, you have a washing machine, you are setting up the timer there, and that is all related to embedded system. And you have a lift, and you are pressing down the key for where the lift has to be stopped and where you need to enter in. Those are all the informations that we are giving in to the logic circuits in terms of zeros and ones. Okay. So for performing any logical operations, many gates can be combined to perform a particular operation that we desire. Okay. So gates can be combined to perform more than one complicated task. And now, how we describe the behavior of the gates? Okay, how do we describe the behavior of gates and circuits? We can describe the behavior of logic gates and circuits by means of Boolean expression, either by means of logic diagram or by means of truth table. There are three possible ways for expressing the behavior of any circuits or the behavior of the gates. What is Boolean expression? It is nothing but a mathematical expression. Like either this mathematical expression, either it may be AB plus BC and AC, for example I am writing, or it may be A plus B into C plus D. This is Boolean expression. Okay, this Boolean expression, it is nothing but a mathematical expression, provided those mathematical variables will take only two values, either 0 or 1. Okay, since its performance is on logic gates, no, binary function, either 0 or 1. These variables only take either of these two values. Okay, this logical expressions also can take only these two values. And logic diagram, for example, for implementing this expression, if I'm drawing a logic circuit, okay, this is an AND gate, we know AB and CD and AC, and then result you add, okay, AB and let me take only AB and CD, and then I'm adding it up. So this is my output. This is said to be logic diagram. This is said to be the logic diagram. And next one is the truth table. Truth table is nothing but how many inputs that we are giving. What are all the possible output that the circuit will give. So the mapping of the input and the output. Okay, the mapping of input and the output for a particular circuitry that we need to design or that we are interested in, that is said to be truth table. Okay, so with that in mind, we have the 6 basic logic gates. I'm sorry, I said 4. 6 basic logic gates, namely NAT, NOT, AND, OR, XOR, NAND, and NOR. NOT is nothing but an inverter where you will be giving an input A and you will be having an output A bar. It will be operated on a single input. And AND is nothing but it's binary multiplication. If I am giving AB, the result will be AB. AB as the input, result will be the product AB. OR is nothing but the binary addition, so A, B, A plus B. XOR is nothing but exclusive OR. This is related by the symbol like this. A, B is the input and exclusive OR output. A, XOR B. Okay. And NAND, NAND is nothing but inversion of your AND output. So in the output, in the logic diagram of AND, if I put a bubble at the output, that is said to be your NAND. And similarly, OR is nothing but the inversion of your NOR is nothing but your inversion of your OR. So I will put a bubble at the output. Let us see in detail. NOT gate, as I said, you have only single input A, and the output, let me name it as X, and X will be A bar. This is the Boolean expression. This is the logic diagram, and the truth table. A input can take two values, 0 and 1, and the output will be, for 0 it will be 1, for 1 it will be 0. So mapping of input and the output is said to be the truth table. And next is your AND. So this is your binary multiplication. X is the output, A dot B is the input. So two inputs you have, 2 power 2, 4 input possible combinations. So 0, 0, 0, 1, 1, 0 and 1, 1. Since it's multiplication, only for 1 and 1 you will be having 1. The rest all output is 0. And OR gate, and 2 input, 1 output, 2 power 2, 4 input possible combinations. X is equal to A plus B, it is binary addition. So even if one of the inputs is 1, the output is 1. So rest for the, except for the first, the rest all input combination you will be getting. And the third one is exclusive OR. Okay, exclusive OR. So again 2 input, 1 output, 2 power 2, 4 input possible combinations. X is equal to A XOR B. This is the Boolean expression. So here why it is said to be exclusive OR is, for OR gate you will be having 3 ones. Okay, but for exclusive OR, for when both the inputs are similar, you won't, like both the inputs are similar, and if it is 1 you won't be getting the output. This is 0. Hence it is said to be exclusive OR. And for dissimilar input combination, for example 0 0 and 1 0, your output will be 1. Okay, and XNOR is quite inversion of your XOR. So put the same symbol, put a bubble at the output, so you will be having XNOR. Okay, so the truth table will be for 0 0 1 and 1 1 and 1. Okay, for similar inputs you will be having 1 as the output. And the NAND gate is nothing but the inversion of AND, and so A dot B, the whole inverse. So other than the last one, for all the input combinations you will be having 1, and this is the logic diagram. You will be having bubble at the NAND gate, output NAND gate. And finally the NOR gate is nothing but the complement of OR gate. And again draw the OR gate, A, B as the input, and the output of the OR gate you put a bubble, that is said to be inverter. So you will be having A, B input, 4 possible combinations are here. So other than the first one, the rest all is 0. This is X is equal to A plus B, the whole bar. With this, the basic, we have discussed the basic logic gates. Thank you.